Hi, everybody. I hope you're doing well today. We're moving on again. So we're still going to be using our law of cosines and law of sines, but we're now moving on to areas of triangles. So normally we know what the area of a regular triangle is, or a right triangle is, right? We know it's 1/2 base times height. But because we haven't been working with our right triangles, we're working with our oblique triangles, which is meaning non-right. We have to come up with a different formula. So those formulas look like this. It's really only one formula. It just depends on what angle you're given. So if you're given angle A, then you're going to use this formula. If you're given angle B, then you're going to use this formula. If you're given angle C, you're going to use this formula. So let's give it a try. So the first one says, find the area of triangle ABC given this information. So of course what you're going to do first is you're going to draw this triangle. So notice you're given angle B. Good, so let's use this formula here, and what works out because we're also given side A and side C, which we need. All right, so go ahead and draw your triangle. I've drawn mine already. There we go. And now what we're doing is we're just plugging that into the formula, plugging what we know into the formula. So our area is equal to 1/2, so I'm going to put 0.5, times A, which is 12, times C, which is 9, times the sine of 150. Okay, so go ahead and plug that into your calculator. Let's see what you get. Let's see if we get the same answer. And I get that the area is equal to 27, and in this case, it's units squared. You don't have to write the full squared, but it's easier for me to do that. So you should have gotten area is equal to 27 units squared. So again, this is just finding the area of a triangle when we don't need a right triangle to find the area. We can find it using this way. Okay, using these new formulas that we've introduced. All right, so why don't you try the next one? Pause it for a second, and pause it for as long as you need to, and then come back to me. And welcome back. Here we go. You try example, find the area to the nearest 10 square units. I think it actually winds up being, forget 10 square units. We want just what the answer is. We'll just do. If you're rounding, we just round to the nearest whole. It's easier in this case. So your area is again 0.5 I'm using times 95 times 71 times the sine of 31. So notice I didn't label my triangle this time. You can if you need to use the formulas. But what really you're doing is you're using the angle that's included between the two sides. And then you're using those two sides that includes the angle. And again, we should have got 1,737 units squared. Okay, good job. Let's go to the next one. So this one's a little bit different. You're looking at this, sorry, I wrote it wrong. Hold on one second. So you're looking at, you have it on your paper. You're looking at that octagon, right? Okay, well, we are not given, let me see if I can show you this. Oh, come on, little guy. Okay, we're not given this angle, so we have to find that angle. No problem. We know that it's inscribed, this octagon is inscribed in a circle. That just means it's inside a circle, right? Okay, so I know that a circle has how many degrees? Very good, 360. So what I'm going to do is I'm going to divide 360, right? 360 divided by, well, I know 8 triangles are going to fit in there because it's an octagon. So I'm going to divide that by 8. And I get that little angle there has to be 45 degrees. Perfect. So now we have the triangle that was inside the octagon. Here's my triangle now. So on my two sides is 9 because it said the radius was 9. And my angle is 45 degrees. And again, that's because we did 360 divided by 8 because 8 triangles are going to fit in here. All right, so now can I find the area of this triangle? Absolutely. Why don't we do the area of that one triangle, I'm going to write area of triangle, is equal to 0.5, again I'm using 0.5 instead of 1/2, times 9 times the sine of 45. All right, again, go ahead and plug that in the calculator. And what we should get is that the area, again, of that one triangle is equal to 28.6 approximately. Okay, that's just one triangle. I want to know what the whole octagon is, right? So aren't there going to be 8 triangles that fit into this octagon? There sure are. So what am I going to do with this 28.6? Excellent. I'm going to multiply it by 8 because there's going to be 8 triangles. When I do that, I'm going to get the area of the octagon is equal to 229.1, and again, we're going to call it units squared. Okay? Does that make sense? All right, so far so good. Again, we're still using these formulas, so that's what our final answer is. All right, and then let's look at the last one, the last example that we have. Okay, so this says find the area of the triangle, and again, to the nearest 10. Let's just do it to the nearest whole. I think I did 10th. I did 10th. All right, so let's write 10th instead here. Okay, so find the area of the triangle to the nearest 10th. All right, using the SAS formula. So again, using the formulas that we just did. But if you notice, we have an issue. What's our issue here? Very good. We're given SSS, not SAS. So this goes back to what we just did with law of cosines. Because remember, law of SSS can be used, or law of cosines can be used with side, side, side. So I'm going to find, because you know in law of cosines, you have to find your biggest angle first. So let's do that using our law of cosines. So I'm going to insert an equation here because it's easier to type it out. So remember what we're going to do is we're going to find the cosine of angle C, and we're going to set that equal to, we have to go back to the formulas that we've just used. We're going to do 6 squared plus 9 squared minus 13 squared. And, oh, did I do this right? And we're going to divide this all. I wonder if I can do this. Ah, shoot, I did it wrong. Hold on. It's going to be a fraction, so we have to, I have to make my fraction first. Sorry about that. All right, so we have 6 squared. Same thing that I just put in the numerator. 6 squared plus 9 squared minus 13 squared all over. And now we're going to the denominator. 2 times 9, or 2 times 6 times 9. Doesn't matter how you do it. Okay, so let's do that. Let's throw that in your calculator. And remember, what do we have to use because we're trying to find the angle? You know it. What do we have to use in order to find the angle? Excellent. We have to use the cosine -1. So throw this all into your calculator. Throw this, right, all into your calculator, and then find the angle whose cosine is. So use that cosine -1, and you should find that angle C, hold on. You should find out that the measure of angle C is, what did I get? 119 degrees. Okay, great. So now I can throw that 119 into here, and now I can go back to the formulas from the previous page, and I can find out what the area of this triangle is. So now what I'm going to use is I'm going to use the 6, I'm going to use the 119, and I'm going to use the 9 for this area formula. I don't need the 13, right? Because now I have my side, angle, side. Okay, so let's plug that in now to our formula. So I have area equals 0.5, right? I'm going to use that 0.5 again, times 6 times 9 times sine of 119. All right, when you throw that all in, what do you get? So the area of this triangle is equal to 23.6 units, and again, squared, because we're talking about area. So this is your final answer, this 23.6 units squared. We just had to go through a couple steps to get there. Again, let's just recap that really quick. I need to have side, angle, side in order to use these formulas. I was able to get that angle by using the law of cosines, using my cosine -1, and then plugging that angle into the formula for my side, angle, side. All right, and that's it. Try the video check-in, and I think that's it for today. So try the video check-in and then have a great weekend because I don't, quote, see you tomorrow. All right, take care, guys. Thanks.